Section 12.5 is entitled Mathematical Induction and Infinite Geometric Series. Now, when you see geometric, you want to think it's exponential, so you divide from right to left. And we are not going to be doing the mathematical induction part of Section 12.5, so what I want you to be able to do is to determine if an infinite geometric series converges or diverges, to find the sums of infinite geometric series, and to write repeating decimals as fractions without just converting them in your calculator. Okay, now in the last section you worked with partial sums, so you might have had to find the sum of the first 20 numbers or the sum of the first 10 numbers. In this section you will be finding sums of some, so not all, infinite geometric series. Now let's look at a couple series here. These are geometric because when I take this term divided by this term I get 1/2. 1/2 here, 1/2 here, and 1/2 here. So this is a common ratio. When I divide, I get the same number. So that makes it geometric. And the same thing here. 1/2 divided by 1/4. 1/4 divided by 1/8. Common ratio is 2. Now, if you look below here, there are tables for the sums. So this is different than what you're used to seeing. Our first term is 1/2. That makes sense. Now they have, when n equals 2, it's 3/4. Well, that is not 3/4. So what this represents, it says partial sums. It means this is the sum of the first two terms. So if I add 1/2 and 1/4, I do get 3/4. And if I come over to 3, I add the first three terms, and I'll have 7/8. Same thing over here. This means, we'll go to number 5. This means the sum of the first 5 terms. So I'm adding 1, 2, 3, 4, all these 5 terms, and then my sum would be 31/32. So again, this represents the sum of the first 3 terms. Now, on the graphs, you'll notice how different they look here. 1 comes up and kind of flattens out, and I just made a dotted line here across where 1 would be. And then, so it kind of flattens out. And here it just spikes, so it just keeps on going. This one is approaching the number 1, y equals 1. So let's see what that means. The partial sum on the left has a common ratio of 1/2, and you can see how it appears to flatten out right here. As the domain or the term numbers increase, the range or the term values, the sum of the term values, appear to be getting closer to a y value of 1. So look at the ratio. The ratio is 1/2. When the ratio or the absolute value of the ratio is less than 1, and you have to take the absolute value. So if you have a ratio of negative 3/4, it's still going to be less than 1 when we take the absolute value. So when the absolute value of your ratio is less than 1 and the partial sum approaches a fixed number, and I kind of say flattens out, so if you see it flattening out, it's approaching a fixed number, so it's approaching 1. The series is said to converge. The number that the partial sum approaches as n increases is called the limit, and you'll work more with that next year and in calculus. So just now know that it's approaching its limit, or the limit. Now looking at the series on the right, you can see that as the domain increases, the range spikes, so it goes up like this, off towards infinity. So when the absolute value of r is greater than 1, and, so both of these things have to happen, and the partial sum does not approach a fixed number, so this just keeps getting bigger, 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 bigger. The series is said to diverge, and it does not have a sum. So if a series is infinite and it converges, we can work on finding the sum. Okay, now, so the first thing you have to decide is the series convergent or divergent? And all you look at is the absolute value of your common ratio. If it's less than 1, it's convergent. If it's greater than 1, it's divergent. All right, so always divide from right to left. So our first example here, we're dividing, and the common ratio is 0.1. So since this value, absolute value of that is less than 1, it's going to converge, and I'm just going to circle converges. Our second one here, if we take 108 divided by 36, we're going to get 3. 36 divided by 12, 3. 12 divided by 4, 3. So since this is greater than 1, we're going to say that the series diverges. So we wouldn't be able to find an infinite geometric series, or the sum of that series. All right, so to find the sum, this one we can find the sum, this one we can't. So here we have S equals, or the sum equals, your first term over 1 minus the ratio. Now this is a comma right here, so just kind of ignore that. It's not an exponent. All right, now we want to find the sum of the geometric series if it exists. So the first one over here, when I divide from right to left, I'm getting negative 0.2 all the way across. So if I take the absolute value, so the absolute value of negative 0.2 is less than 1. So that means that it converges. So I can find a sum. Now in order to find the sum, I have to it's pretty easy to find. The sum equals the first term, so my first term here is 1, and then I divide it by 1 minus the ratio, and again that's just a comma, it's not to the first power. So my ratio is negative 0.2. Okay, so when I divide that, I'm going to get that the sum is, and we'll just write it as a repeating decimal here, 0.83, and that's going, or just the 3 part is repeating. So let me take that off here, off of the 8. Okay, so it's just 0.83, and the 3 is repeating. All right, now we can see it like this, or we can also see it in summation notation. Now this is going to be your ratio, and so our first term, we need a sub 1, we need our ratio. So that's all, basically all you need, first term and your ratio, common ratio. So our ratio is 1/2. In our first term, so a sub 1 would equal, we would just say 1/2 raised to the 1 minus 1. So that's just going to give us 0 right here. So 1/2 to the 0 power is not 0, it is 1. So a sub 1 is 1. All right, now I'm going to use the series, infinite geometric series, and say that the sum is going to equal my first term, which we found was 1. That goes over 1 minus my ratio, which is 1/2. Okay, so now we have 1 over 1/2. Or the sum equals 2. All right, on the other side, we're going to write a repeating decimal as a fraction without a calculator. So what you first need to do is write it as a geometric series. And the way that you do that, and I'm not going to write it out as a line because I think it's easier to see if I write it one right underneath the other. So what I need to do is take it apart, and when I add it up, I need to get this. So I have 0.63, and it keeps repeating. So now I need to put zeros under here, and then I put the 6.63 or 0.0063 here, and then same thing here. I'm going to put zeros underneath everything that's above it, and then I write the 63 again. So if I had 3 numbers, I would have, my next term would have 3 zeros, and then I just keep going here. Now a series, these would be added together. So now I need to find their ratio. And I just go divide. You're always from right to left, but this is going to be top to bottom. So when I divide, I have 0.01 here, 0.01 here, and 0.01 here. Okay, now I just use the infinite geometric series to write the sum. That means I take the first term, which is 0.63, and I put it over 1 minus 0.01. So that's going to change. My sum is equal to 0.63 over 0.99. And when you have a fraction, you should not have decimals in your fraction. So if we move the decimal over 2 places here, we can move it over 2 places there. That's going to give me S equals 63 over 99, and that can be reduced. So your sum is going to equal 7 over 11 when you divide by 7. Okay, you have a few questions to try on your own.